prove that curl of vector R is equal to 0. Curl of vector R equal to 0. So first of all, we have to write the vector R as x, y, I cap, y, j cap plus z, k cap. And then how do I write the value of curl of R? We have to present it in the form of a determinant. So curl of R. So when I write this operator cross R, which means curl of R, a vector R, which we write down in the form of a determinant, that is I, j, k, del x, del y, del z. And then for vector R, we have the x, y and j representing I, j, k. So x, y, z. Now I start computing the value of this. So when I have this, you know how to calculate this determinant. So when I have to calculate I, the first row and the first column will be switched off. So I write this first row and the first column will be switched off. So I have I, bracket open, this and this. So del y of z minus del z of y. Again, when I have the second column, first row and the second column, that is minus j. Remember, I have to include minus j. And I have del x of y, of del x of z, because the second column will be switched off. First row will be switched off for j, the second part. That is del x of z minus del z of x plus k vector. So in this case, the third column and the first row will be off. The third column and the first row will be off, and I have k vector del x of y minus del y of x. So this part is very important. To compute the value, determinant value, when I start with the unit vector I, the first row and the first column will be off, and then the cross. Then for minus j vector, the first row and the second column will be off, and for the plus k vector, that is the third term, first row and the third column will be off. So now when I compute these brackets, I have del z by del y and del y by del z, both are 0. So this value is 0. This value is also 0. Even the third value is also 0. So I have 0 plus 0 plus 0 gives 0. That proves that curl of vector R is equal to 0. This was easy, but very important. Now, related to curl, I have another important question. So let me write down the problem. What do you mean by e-rotational vector? E-rotational vector, and show that vector A 6xy plus z cube I cap plus 3 x square minus z j cap plus 3xz square minus y k cap is irrotational. So let me define what is an irrotational vector. So in terms of condition, a vector is said to be irrotational if curl of vector is equal to 0. So this is important. So when I say that curl of that vector is 0, so if I say vector A, in this problem vector A, so curl of a vector A is 0, then I say it is irrotational vector. Then I infer that this is irrotational vector. Okay. So let us prove that this vector which is given A 6xy plus z cube I cap plus 3x square minus z j cap plus 3xz square minus y k cap is irrotational. So what I have to prove? I have to calculate the curl of this vector which to be 0. So let us start. The value curl of a vector A is equal to I j k del del x del del y del del z. Okay, and the first part of vector A, that is 6xy plus z cube. The second part is 3x square minus z, and the third part is 3x z square minus y. So yeah, I have to follow the same step which I have done for curl of R. So to calculate the curl of A, I have again the first row and the first column will be switched off. The first row and the first column will be switched off, and I have del del y of 3xz square minus y minus del del z 3x square minus z, then minus j. First row and the second column will be switched off, and then cross del del x of 3x square, 3x 3xz square minus y minus del del z of 6xy plus z cube plus k vector or k cap. Then the first row and the third column will be switched off, and I have del del x of 3x square minus z minus del del y of 6xy plus z cube. So when I do this, and now I have to do the derivative, partial derivative for every term, that is first term, second term and the third term, considering the bracket terms also. While doing this, I calculate the curl of A. So curl of A, if I consider the first bracket here, the first bracket, del del y, and when I do del del y, that means I am doing the derivative with respect to y, and in the bracket it is 3xz square minus y. So other than y, I have all the terms to be considered as the constant or as a constant. So I have I cap, when I have this del del y, I have minus 1, and the second term I have plus 1, then minus j cap, again del x of this term and del z of this term, which I have as 3z square minus 3z square, then the plus k vector, unit vector, del x of this term and del y of this term gives me 6x minus 6x. So I have 0 plus 0 plus 0, which gives finally curl of A to be 0. Thank you so much. So we can say that curl of A or vector A is a e-rotational vector.